two poles of a permanent magnet and a soft iron cylinder. The air gap between the magnetic poles and iron core is small and the flux density is the uniform and is in a radical direction, so that the flux lines are always at right angle to the current carrying conductor, and hence when current passes through the coil, a deflating torque is produced owing to the interaction between the two fluxes, one due to permanent magnet and the other due to the magnetic field of the coil. This is shown in figure 4.2. Aqueous permanent magnet, soft iron core, pole piece coil, spring. Construction. So the various part of a permanent magnet moving coil instrument in consists of a light rectangular coil of many turns of fine wire wound on a aluminum former inside, which is an iron core as shown in figure. The coil is delicately pivoted upon jewels bearings and is mounted between the poles of a permanent horseshoe magnet. Attached to these poles are two soft iron poles, piece which is concentrated the magnetic field. The current is led into or out of the coil by means of two control hair springs, and above and the other below the coil. This spring also provide the controlling torque. The damping torque is provided by eddy currents induced in the aluminum former as the coil moving from one position to another position. Working. When the instrument is connected in the circuit to measure current or voltage, the operating current flows through the coil. Since the coil is carrying current and is placed in the magnetic field of the permanent magnet, a mechanical torque acts on it. As a result, the pointer attached to the moving system moves in a clockwise direction over the graduated scale to indicate the value of current or voltage being measured. If the current in the coil is reversed, the deflating torque will also be reduced since the direction of the field of the permanent magnet is the same. Consequently, the pointer will try to deflect below zero. Deflection is the direction. Reverse direction is prevented by a spring. Stop